That's why we're live on video on YouTube. All right, welcome back. We are game 3001 in the winter 2021 semester at George Brown, and it's artificial intelligence. It's week 2, part 3 of our broadcast. And we just finished setting up a custom game object for our lab. That was your homework for last week. And now I've given you the starter. Most of you are in, and the starter is right here, lab 1 GitHub link. And this is where we're starting off with at this point. So I've talked about how we've put the object in the scene and so on, and we're going to continue with the next piece. All right, so now that I have a game object, and again, if I run this, I see there's a little game object on the top left corner of the screen. I want to have a target. I want to have a target that this thing is going to seek. We're going to work on seek right now. So this is the part that's going to be the important part for you guys. Hopefully you guys downloaded the starter and you're ready to go. All right, so in order for us to make something, I want a new object called a target. And what I've done is inside game object, there is indeed a target game object. The target game object is just a blue circle, okay, that you're going to see. So I want to include the target inside of my playscene.cpp and the playscene.h. So let's go to the playscene.h first, and I'm going to make a new target. So I'm going to say, hey, I want an object of type target, and I'm going to call it m_p target. Okay. Target doesn't compute. You have to include the target.h file at the top, and ReSharp or C++ will do that for you, or you can just type it yourself. So now that I've declared an object of type target, and I called it m_p target, m for member variable private pointer called target. That's what this is. Then I can go ahead in my playscene.cpp, and in my playscene.cpp, just like I put the, in the spaceship, before the spaceship, let's kind of add the target object. So I'm going to say m_p target is equal to a new target. And we're going to say that m_p target get transform position is equal to a new GLM vec2 object that starts off at the middle of the screen, 400.0f and 300.0f, approximately. And then we're just going to add the target to the scene. Add child m_p target is how simple it will be to add this in. Okay. Are you with me? Hopefully you are. I'm not going to ask you for check marks yet. Hopefully you are. If I run this now, then I should get no errors and something that looks like, let's see this in a second, this, a little blue dot and a spaceship. It's not exciting. Okay, it's not very exciting. Remember the algorithm that we saw. What we want is for our spaceship to navigate to the target. Again, I'm going to start with seek. For you guys, you're going to work out the rest, right, of some of the stuff, but I'm going to talk about how to do certain things and kind of my methodology. Alex might have a slightly different way of doing things, and that's okay. But I'm thinking about, hey, I got a ship and I've got a target, and I want to navigate from where the ship starts off, to the target. That's what I want to do. I'm just going to stop my video so I can put my video up on YouTube, and so that way people can see me while they're up on YouTube. There we go. All right, so this is the first part. So now, question for you guys, since you guys are live, where would I put my code? How do I make it happen? Should I put my code for the navigation of the ship? Should I do that in the playscene.cpp? Should I do that inside of my ship? Should I make a new class? What do you recommend? Nick says on the ship. Anyone else have any other options? Update on the ship. People say the ship. A new class. A new class isn't a bad idea. Maybe we'll do that later on. For example, if I wanted to make an AI brain kind of class, that might be a good spot to put kind of a component, and then add that component, plug that component in, to something that's an agent. I can make a brand new game object type, which kind of inherits from display object. It's a special type of display object that also has, kind of an autonomous agent built into it, right? Right now, we're not going to go into that level of detail. We're just starting off very simple without making more structures. I just want something to move. Okay, so that's what we're starting off with. Okay, so now that I have a target and I have a spaceship, I need to navigate to it. Yes. I was asked to navigate back to my placing.h. All I've done was I added in a brand new target and a include. That's all I've done here. All right, so then all I'm doing is, like, again, if I go back to the start, then I'm just putting in a new target. I'm allocating memory. That's what the new keyword is for on the heap. And then I'm setting the position to a new GLM vec2. So vec2 means a vector2 object, x and y coordinates, right? I'm setting this up and I'm storing it inside of the position property of my transform component of my target. That's what it is. Okay. Now, the next part. So some people said I should set it up inside of my spaceship, right? As an example, here's my spaceship. And some people said I should put it in my placing. I don't recommend placing. Maybe I'm going to put other things in my placing. And the blue dot should be, if you didn't add child, then you won't see the blue dot. So again, the blue dot is in your placing. You should have add child m_p target. Make sure you do that. Okay, so again, are you getting any errors, Miguel? So if you are getting any errors, then there's something else going on. All I did was these three things, right? So you should be able to do the same thing. If you downloaded my starter, you should see what I'm seeing, which is this. Awesome. Thank you, Devin. It'll take a bit of time because, again, I'm running in debug mode, number one. When I'm running in debug mode for the first time, it's going to do some indexing, right? By the way, if you ever try to run this, right now you notice that it is running in debug mode. If I wanted to, well, do you think it'll run in release mode? Release mode is like a non-debugging mode, just letting you know. And if you try and run your files in release mode, it'll do a couple things. First of all, it may fail. I've fixed it a couple times, so it doesn't fail. But what it does is it'll run without debugging, all right? And you can see that there's several errors because I need to set up there's some stuff I have to do with the template. So this is not so bad. The optional is not a member of STD is part of the error, and I can fix this later on. So just bear with it. It doesn't run in release mode right now, but we can fix it. It's running in debug mode, no problem. I'm just letting you know, just in case you decide to run it in release mode, it won't work. The include for target.h is definitely in the placing.h. So that's where it's up here. And that happened automatically or automagically with, ReSharp or C++. All right, now you should get this. So my question is, I want to make this ship just go directly to this thing. So I don't want to make it like, look where it's going right now or anything, just simple movement from here to there. I want to trigger. Here's what I want. I want to trigger. So I want to be able to turn on and turn off the ship moving, and I want to be able to reset it back to this position. I want to also be able to move my target around anywhere I want in real time. This requires a user interface. And my recommendation, of course, is my friend, IamGUI. This thing. I could certainly make buttons that we can make work, okay? However, I recommend that IamGUI is probably the simplest way to make it go. Let's turn the ship on and off for now. Let's do that first with some buttons in IamGUI. So let's go into my placing.cpp. I'm going to scroll down to where it says GUI function. If you want to, you can go from a scope perspective, change to placing, and then navigate to where it says GUI function. That'll actually just teleport you there or jump to that point. Okay. The GUI function already has a bunch of things in here. It has a button called My Button. and it has a slider, which is slider 3. All right. I want to change the slider to a slider 2, and I want to change the button. I want to add 2 buttons, one button that says start and the other one that says reset, that's sitting next to each other. Okay, let's try this out. We can get fancy afterwards if you want to. So first of all, let's rename my button. And again, I'm sitting inside the GUI function inside placing.cpp. I'm going to change the my button. It's going to say start. Let's get rid of this little cout. We don't need it anymore. And what start is going to do is it's going to enable the ship. And by the way, all objects, I can disable game objects in the scene. And let's do that by default for the ship. So by default, let's go into the ship, m_p spaceship, and let's set enabled to false. What this does is it stops it from updating, and it also stops it from drawing, similar to what happens in Unity. So set enabled to false. That just turns it off. Okay. What I want to do is when I click start in the UI, the IAMGUI function, I want to m_p spaceship, I want to set enabled to true. So I want to turn it on. Let's start with that. Okay. So again, I just put set enabled to false for the spaceship. I want to turn it on when I click start. Let's try that out. So again, I'm going to run it. I'm going to press backtick, which brings up my IAMGUI. Again, it's the key underneath the escape key, which is also the tilde. And now I have start, right? And if I click start, then boom, the spaceship appears. Okay. That's what you should have. And it should work just like that. All right, let's make another button. Okay. Underneath the first one, I'm going to call it reset, and we're going to set it to false. So starts it, reset makes it false. And I also want to set its position by default back to where it was before, which is at 100, 100 for now. So I'm going to say that let's set the ship's position back to 100, 100 and set enable to false, which will hide it again. Where's the line that has the keybind or IAMGUI window? Are you talking about to turn it on? Keybind is up here. So, typically what it is scan code escape stops everything. And what I've done is I've set the backtick as the keybind for the default keybind for the stuff, and that should be inside of your event manager, if I'm not wrong. So in event manager, there's a bunch of different events. Here's the IAMGUI stuff, right? And what I've done with event manager.cpp is I've set it up so that way when I press the backtick character, right? So there's a bunch of different things here. Here is the backquote. And again, this is in event manager.cpp. It will enable the UI. IAMGUI is active. And so it'll show it to you. It'll only do it in the event manager. So I've hidden it away from your placing. It's not placing related. Okay, so every time I press the backtick, it'll just hide the IAMGUI function. All right, so back to this. So now I've got a reset button, but I want to put them next to each other. I want to put them on top. If I just leave it like this, start and reset, they're going to be on top of each other. Let me show you. So by default, if I run backtick, you can see that the start and the reset button are on top of each other. I want to put them next to each other. So what you can do is you can say IAMGUI, same line. And I can just leave it like this as a default, and it'll put it right next to each other, like touching. So again, if I go back and run it again, then you should see the two buttons are right next to each other for the most part, with a bit of separation, the default value for separation. Okay, so start, reset. Okay, yay, awesome. All right, is there a way to make them separated even more? Yes, there is. You can actually put a value inside this, as much of an offset as you want. So you can make it so that they're very far away from each other. Let's say, for example, I add in, I don't know, 600.0f in here. Then what you can do is if you run this now, it'll be like very separated. So if I run it now, you can see that it's like way off screen, like start and reset, like way over here. And you can control how much you want in there, in this area here. I'm just going to keep the default. All right, so now that I've got this this working, nice. Let's change the area. Notice that there's also a separator. Separator is nice when I have some kind of UI and then some kind of different UI down below. So now I have a slider. Instead of making it a slider 3, I want to make it a slider 2. Instead of a float 3, which is just a an array of 3 floats, right? I'm going to call it float 2. I'm going to make it an array of 2 floats. Just going to rename everything so it looks okay. And I don't care about this right now. And I don't care about anything here. I don't care about these things. I'm going to rename this from my slider to target. All right. So the target. And the range is what you see here from 0 to 2. 2 is too low. Let's make it this like 800. So I can put it anywhere on the screen that I want. If you want to, you can put it off screen too. You can be more complex here and you can make each individual slider like a float 1. So you can slide one at a time, but I'm making a 2-dimensional slider here. Let's see what happens, Nick. So again, float 2. So float 2, it says a integer, 2 integers is what I have here. All right, this is just a Visual Studio thing. What I want inside here is, instead of me putting 0 and 1, I want to initialize these values with the target. So m_p target dot get transform dot position dot x, and the same thing, get position dot y. Right? So I can set the float 2 to the x and y coordinates by default of the target object. Now, when I change these values, I want to change these values. So I'm going to say something like m_p target. And again, it's get transform position is equal to a new GLM vec2 object that I'm going to take in float 2 0 and float 2 1. Again, there's just 2 floats. Alternatively, what you can do is you can make this probably a GLM vec2, and then it'll have all this information stored up. However, it wants a static float array. If I hover over this, it says that that's what it wants, a float array. Okay, so that's what I've given it. Also, what I want when I move this object around, this is the object, right? Let's see how this works. So if I run it, and Nick, I'll answer your question in a second. If I run it now and I press I'm GUI, you can see it's 400 and 300. I should be able to move this up and down now because I'm moving this around. Okay, so I can move my target anywhere on the screen pretty much that I want. And you can also, you should be able to, you can't type in there. It won't allow you to type. That's a thing that it won't allow you to do, but you can move this around. If I want, as an example, I could create a little toggle that resets it back to 400 and 300 if that's what you want. Let's say 400 and approximately 300. If you really want to, because it's hard to get there just by using the dial. Okay. So sometimes it's easier for us to click a button to get us back to the middle. Nick, did you fix your problem? No. Okay. So again, 2 buttons, start, set enable to true, and then reset, set enable to false. And then every time I press start or reset, it changes back. Let's try this out and see if it works for me. So run. If I press start, it makes the object. Notice it draws on top of everything else. Reset, puts it back. Start again. Reset, start, reset, start, reset. Should do that for you too. If it doesn't, maybe there's something else that you did differently than me. So that's how it should work. Set enabled. Notice that by default, I start disabled. When I hit the backspace, you mean the backtick, Vash? I don't see the start reset buttons. I only see the my button. Well, that means either that this isn't updating, which means make sure you save everything. You should be able to save everything and it should run. Sometimes it doesn't compile, right? But typically it should. So I've just removed the button. The buttons are called start and reset right here, and I put a same line here. I'm going to put this up on GitHub in a second, so it should be able to be clearer for you in a second. 101,000. There we go. Okay. My circle's not moving. Okay, well, the circle, the way it's going to move is you got to set the position to a new GLM vec2 every time you move the float. So notice I'm getting float 0 and float 1. Make sure your code looks like mine. And I want to be able to move my stuff around, because if I can, then I can, instead of me always rebuilding my scene over and over again, I can fix it, I can play around with it, live, and it'll save me a lot of time. So I can do a lot of tests with it without rebuilding. Okay, let me put this up on GitHub for you guys, so that way you have everything that I have. I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. In here, notice that there's a bunch of changes. I'm going to stage all of the changes that are in here. Again, you can do this with a tool like Gitkraken if you want. I'm going to say that I added target with IMGUI support is what I did. Commit staged. I'm going to go to Home. I'm going to go to Sync. I'm going to go to Push, and then you're good to go. It should push everything up on GitHub. And so you can compare my code with your code. If you did that, if you want to compare, remember that on GitHub, it tells you, if you refresh, it tells you how many commits I have. And notice where it says added target with IMGUI support. If you go into the template or into the files, normally it's inside the SRC files, it'll show you the files that have been changed. So it says added target with IMGUI support. Notice I changed the playscene.h and the playscene.cpp. And the spaceship.h, and the spaceship.cpp was also changed. Okay. Those are the changes. You can always remark on which ones changed with this particular commit. All right. That's good. So now the next part. I really haven't added any code to seek the target. In order for me to do that, I need to find the almost like a destination that I want to share. So in my spaceship.h, I want to create a new member variable called destination, and it's going to be of type GLM vec2. We're going to call it m_destination. It's not going to be a pointer. It's just going to be a vec2. I need a setter for this. So here's getters and setters. I'm going to make a brand new setter called set destination. And in my set destination, it's going to take a vec2 object, GLM vec2 object, That's going to be called destination, and it's going to return void. Okay. Again, this is in the .h of spaceship.h. So I made a private member variable, which is going to hold the destination in place, and my setter, which actually sets the destination. Okay, let's fix this up. So I'm going to go here to the light bulb and go to generate implementation. In my set destination, it's going to basically say that m underscore destination is equal to destination. In here, when I do that, I also want to set my destination to const. Let's go back to that, to const. There we go. So you're going to ask, like, what's the point of setting a destination? If, why don't I just make it public? And remember how object-oriented rules work. Public properties, or setters and getters and setters, private instance variables. And this promotes something called information hiding, right? So you don't want to necessarily have direct access. And sometimes this is a method, so I can add other things in here. I can do some logging. I can affect other methods, as opposed to if I directly access my m underscore destination variable, I can't do anything. I only can set values. I don't want just to set values. That's not good practice. And that's why we have our getter and setter. It gives us the ability to, if we want to, add more details inside the method, as opposed to not. Okay, next. Now that I've set the destination, in my update, I want to move my ship towards the destination when it's updated. Eventually, Neil. Yeah, hopefully. Let's see. Let's make a new method called move. It's going to be a private method. So again, I'm going to go into my spaceship.h. I'm going to go into the private area, and this time I'm going to make a private method called move. It's going to return void, right? It's going to be called m underscore move, capital M. And the method's not going to do anything. It's just going to basically have some move code in it, and it's going to be separate from my update. So I'm compartmentalizing. That's all I'm doing. I'm just organizing in my move method. Remember what we talked about maybe at the beginning, which was you don't want to repeat yourself. So dry, do not repeat yourself. And also, we want to think about the single responsibility principle, which is every method just does one thing. Okay, so let's go back to my spaceship.cpp then, and we're going to call the move method here. So I'm going to say, hey, let's call move, right? Move has never been defined. Let's define it. And again, you can go to spaceship.h and go to your little light bulb and generate implementation. There's move. How does this work? So move is called an update. Every update, move is called for the spaceship. This is okay. How do I want the move function to work? Well, I want to seek towards the destination. So the first thing I want to calculate is I want to calculate my direction. I want to change the direction, and I want to hold the direction in memory somehow. So that means another variable. Let's go here. So destination, and we're going to say the target direction, or you want to call it the, whatever you want to call it, the direction that I'm moving in, right? So GLM vec2, we're going to call it, the target direction, kind of a longer one. So target direction, right? Again, destination and target direction are two different things, right? Destination is where I'm going. Target direction is my, my normalized values I can put in there. All right, so then what I want to do is I want to calculate my target direction and destination. So I want to say that my target direction, m underscore target direction, is equal to my destination minus my current location. So that is get transform dot position. All right, remember we did this? Target direction is the difference between where I'm going and where I am. But this gives me my magnitude. So magnitude, right? I don't want the magnitude, right? So a length that's from one, I'm going to draw a line from one to the other. I don't want this. I want this to be normalized. So the way to normalize it is to do this. M underscore target direction is equal to my my M underscore target direction normalized. So how do I get that? The normalization, I use the utility function for that. So util colon, and notice it says, do you want to include util? Yes, I do. And normalize, and it takes a vector too. So I'm going to pass in M underscore target direction. Can I do this differently without having extra variables? Yes, I can. I could put all of this inside of here and then set that to target direction. So I can do all that in one. So this is the normalized value for my target direction. Okay? This is my direction with magnitude. Right? So this is like the actual value, the total length, right? It's like drawing a line from point A to point B. This one isn't drawing a line, it's just pointing at it. How do I access util? You have to include it as an include. I just did that with ReSharp or C++. It did it for me. They do. They do work a little differently. They don't have the same level of functionality. Unity has some really cool stuff, and we can add some of them ourselves. They're different. They're very different than Unity, right? Again, if I was going to make my own vectors and my own matrices, there's a lot more code. So I elected to download and install GLM, and it's going to help you guys because later on what's going to happen is when you use OpenGL, you're going to use GLM. So it's good to learn about this now. Okay, it does not do that kind of stuff. Can you show again what you did in Spaceship? This isn't Spaceship, spaceship.cpp right here. So are you looking at spaceship.h? Spaceship.h, I did two things. A few things. I set my getters and setters, set destination. I set up a destination GLM vec2 as well as a target direction. They're different. So where I'm looking, what the direction is, where my destination is, and what's the destination. Okay. So GLM is the graphics library. You don't have to include that here. It's automatic because I've included it in display object and texture manager. Okay, so that is destination and target direction, and then I'm moving. The moving function is a private function. So this is what this is, private function, right? That does move. And I don't need to make it public because I don't need to access it right now from outside of ship. Okay. And inside my spaceship.cpp, then I've only put the move function in update, and I've started to set up move, which right now calculates the destination and the target direction. That's all it does. So hopefully that helps you, Vash. All right, next. So now that I have the target direction, this is going to happen every frame. If I put it in move, this is going to recalculate the target direction every frame. Why would I want to do that? Well, that's if the destination changes. If I did it once, let's say, for example, I set the destination, I did it one time, then I wouldn't have to calculate this every frame, right? I only do it one time. But I know that eventually what I want is for this thing to go where it's looking. Right now, it's not going to go where it's looking. It's going to move laterally towards the item. Next, what I want to set up is now that I have my target direction, I want to calculate my velocity. So I'm going to say that get rigid body velocity, and I'm going to make it equal to GLM vec2, and it's going to be, I want to multiply it by my target direction. So really, if you think about it, my target direction is, instead of doing this, I can just say it's m underscore target direction. That's the normalized value, so from 0 to 1, multiplied by some speed, max speed, whatever the maximum speed is. I don't have a maximum speed value. Let's make one for our file. So again, we're going to go back to spaceship.h, and we're going to say max speed is here. So GLM vec2, actually it'll be a float, m underscore max speed. And what I want to do is I want to set the max speed somewhere outside of here. So I'm going to say void set max speed to some kind of floating point value speed. And let us generate my implementation. Again, all I'm doing is setting up a max speed variable and setting up the max speed outside. I allow a setter to do the setting for me. I should, by the way, initialize this because it's not a GLM vec2, and I'll do that inside my constructor in a sec. All right, so spaceship.h and spaceship.cpp. Spaceship.cpp basically says that m underscore max speed is equal to speed. C# or C++ tells me to make this a const, which I will, and I'm okay with that. Couple of setters. Now that I have my max speed, I want to multiply my target direction by max speed. Okay. But we need to set up the default value of max speed in somewhere, or it'll complain. So we need to go to my constructor function, and I'm going to set my max speed by default to 10. So I'm going to go to here to spaceship, put a comma, a colon, and I'm going to set m underscore max speed is equal to 10. Okay. By the way, initializing member variables in your constructor is far better to do it this way than to do it in here if you can. Unless you have a setter or something. I could also set it. So instead of doing it this way, if you wanted to use the setter, instead of doing it directly, you could come in down here and say something like set max speed. That's also acceptable to 10.0f. All right. Both are acceptable. Set max speed accesses the setter, while this does it directly. At least here we can see it, and we know what that is. All right, so now that we've set the max speed by default to 10, we can set it outside of the function if you wish to something else. Cool. So when it runs, we're going to move, and we're going to set the velocity. And the next part is going to add the velocity to the position every frame. So we're going to say that when we're moving, then we'll say that the, again, by the way, target direction, it's important for us to add the target direction in this case, the way we're doing it. But what we want to do eventually is we'll kind of decouple those things. So get transform, and the position is equal to, or sorry, we'll say plus equal to get rigid body velocity. Okay, so all we're doing is we're adding velocity to position every frame. There's no acceleration right now. Sorry, so Neil, why? Which one was why? I missed that one. That's your question. Oh, it's the compiler likes it more if you initialize with a colon as opposed to putting it in the constructor function. It's the right way to do it if you're going to initialize correctly. All right, so cool. I like this. Let's see if it works. So again, we've kind of finished off the move function. The move function is going to be called every frame on update, and only if this thing is active. If it's not enabled, it won't move. All right. We're going to set the destination every frame, and we're going to set the maximum speed to whatever it is if you want to. Okay, and then we're going to move. So pretty simple movement. This is not going to satisfy your requirements for your assignment, but it's a start. Let's continue. Let's run this thing and test it, see if it works. Yep. So I'll do that in a second, guys. One sec. So the way it should work is if I start, then, oh man, what the heck? Well, of course we did that because we never set the destination ever. We need to set the destination outside of here. Okay, before we get there, let's go back to max speed is equal to speed has equals underlined. Okay, max speed is equal to speed. Speed is a float, and max speed is also a float, right? Max speed is also a float, and that's why it should work. Shouldn't be a problem. We're not making a GLM vec2. Make sure it's not a GLM vec2. It's a float. Let's fix up that problem that we just had with const float's fine. Yeah, const float. That's inside of the, not here. Don't make it here. Don't make it a const float here. You make it a const float on the other side, on the when we do this part on here. So on the .cpp, you can make it a const float. On the .h, you don't. Okay. What's the coding to the include util? You just go include util.h. All right, so now let's fix it. Let's go to placing.cpp. And what I want to do is when I put the spaceship in play, the target is already in play. The spaceship is going to use the target as the destination. So we're going to say that m underscore, I'm inside the placing.cpp, m underscore p spaceship. And we're going to say set destination to m underscore p target. We forgot to do that. So that's the destination. It says no suitable constructor exists to convert from target star to GLM vec2. Oh yeah, sorry. M underscore P target get transform position. I'll be all right. We could probably make an overload for that. All right, well, I want to do this too. I want to do this as well. Inside, whenever we move my, whenever I move my target, I also want to reset the target in here. The destination for the target is going to change. Well, then I want to change the spaceship's destination too. So I want to put that inside the slider. So it's both places. It's here for the first time when initializing spaceship. I do it for the first time. And then I also do it inside here when I change the slider float. All right, now it should work. Let's take a look. So if I go back and if I press control, or sorry, if I press backtick and I press start, then it should see this. And you'll see it jitter like this because remember this is a kinematic seek. And what we've also done is that we don't have arrival right now. This is just basics, and it's not looking where you're going. It's just moving aside, which is not realistic. We haven't done that part yet. Okay. So that is kind of very simple way of moving this around, right? I can move the target anywhere I want, right? And the ship is just going to go to the target. And it's going to keep on going back and forth and not stop forever until we reset. Okay. Still can't get the spaceship to move. Okay, let's go back and let me put this up on GitHub, and then you'll have my code and you can compare your code to my code. Where do we add the m underscore spaceship set destination position? There's two places. I want to add it inside the slider float for the first time here. Whenever I change the slider, that's what this means. If I change the target destination to something else, then the destination will change in the ship. And for the first time, I'm doing it upon initialization. So whenever I initialize my spaceship, so this is like, declare spaceship properties, right? Instantiate the spaceship, let's say. So that's actually what I'm doing. I'm instantiating the spaceship. Right? And then the properties go in here. Yay! You guys should be able to get that going. All right, so that's how this works. And again, when I start, I enable everything to move. When I reset, I disable it. All right, that's what happens. Let me put this up on GitHub so you can compare your code with my code, right? To make sure if there's a problem, why it's not moving, compare your code with my code, which is important because I know that watching somebody code and you doing it like I'm doing it, you might be missing something, and there's a lot of code to go through. It looks like there's a lot actually, but it's maybe just one line of code that you're missing to make it work. So let's do this. I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. You can see that I've changed all these files, right? I'm going to stage changes. And I'm going to say that I added simple seek to spaceship. Okay, simple seek. This is like super simple. This is not even the proper way of doing it. Commit staged, home, sync, and push. All right, so now what I'd like you to do for people who can't get it to work is go up online, take a look at your GitHub, compare your files. I can take a look at the stuff that you have too, but more or less what you're looking at is the changes. So the changes are, you can see that I made changes to add simple seek to spaceship in playscene.cpp. That's the one place I added it. I also added simple seek to spaceship in spaceship.cpp and spaceship.h. Compare those things and see that your stuff matches my stuff. Ethan asks, why is it so glitchy when it reaches its destination? It's not glitchy. It's exactly what we told it to do, right? Remember that we're not doing arrival. We're doing seek. So what it's doing is it's going to continue to seek. And let me explain what's happening here. Let's just redraw this just for a second so you understand what's going on. And it looks glitchy, but it's really not. So I have my destination. Actually, let's draw the destination in a circle, just to be realistic. Let's make my screen. So here's my screen. And let's say in here, there's my destination. Here's my destination. And then I have my ship, right? Here's my ship. And what's happening is my ship, which is here, right? Actually, I wanted to do it this way. My ship, what's happening is it's doing this. It's going every frame. It's going towards the thing, and it's moving 10 pixels every frame, 10 pixels every frame. That means that it's probably going to get here and then overshoot. And then it's going to go back this way and overshoot. And it's going to go back this way and overshoot and overshoot and overshoot and overshoot. And it's going to keep on going back and forth like this really fast, right? Okay, that's why it does what it does. Okay? And it's meant to do that because we didn't do any smoothing, right? When we're getting there, we immediately go to max speed, so we accelerate to full speed right away, right? What's happening is whenever we change direction, we're not changing direction. It's literally just moving from one place to the other, right? All right, so let's improve. We can do better. We can do better than this, right? This is just the first part. We can do better. So what we want to do right now is we want to point, or we want to look where we're going. So looking where we're going is a different kind of algorithm altogether, right? And this is kind of the most complex way of doing it. The way to look where we're going is we have to determine a direction, a default direction that we're looking in, okay? So let's use some, some markers to help us, right? the way I'm going to do this right now is I'm going to draw a line, right? A little line outside the ship before we go into anchors and all that kind of stuff to help us understand how this is working. Okay, because right now we can't see anything. When we run it right now, we don't see much. We just see the ship, right? So when I run it, I start it and I see the ship, and it's going to kind of diagonal this way, right? Let's add some more control, right? First of all, let's make it so I can change the ship's speed, right? And I want to change the ship's speed through IMGUI, all right? So I want to go into my playscene.cpp and scroll down to where IMGUI is. We've added some areas here for my start and reset, and I have what looks like a slider float for my target. And what I want to do is maybe somewhere up here, I want to put a slider float for my ship's speed, right? So again, let's see if IMGUI has other kinds of floats. So if I type in IMGUI, and if I type slider, it has the following: slider float 2, slider float 3, slider angle, right? Slider int, and so on. I want to use a slider float just by itself. A slider float takes a label, a float pointer, a minimum, a maximum, and some other things when it comes to the format that I want. Okay. So it's very similar to this slider float. So we're going to call this one, right, the ship's speed. So we'll call this max speed, right? That's the thing. We're going to make it so it's a float. We're going to call it a float 1. Bear with me. Static float 1. All right. We can also call it ship speed or whatever. And we're going to set this to a default value of 10.0f. All right. Actually, we can do other things, but let's set it to 10.0f for now. That's the first thing. The second thing we need is a minimum and a maximum value. So the minimum would be 0.0f, let's say, and the maximum would be something like 100.0f. Okay. And by the way, if this is wrong, right, the reason why this is wrong is it needs an ampersand ahead of it, right? Because remember that these ones are arrays, and this one is just a single float. Okay. We're going to say that if the slider float changes, right, then I want to change the max speed of my ship every time it changes. So I want to say that m_p spaceship dot set max speed to what? My float 1 value. Okay. By the way, these names can be changed because these are terrible names, right? Float 2, really what we're talking about here for float 2 is, what should this really be? What should this be called? Kind of coordinates, if you will, as an example, or we can say target coordinates, target location, target position. Let's call it that. Let's rename. So refactor rename, because this is an ugly name, to target position. Okay. And we can do the same thing when it comes to our float 1, which is what it needs. We can refactor, rename to something reasonable like speed, right? Okay. All I'm doing is refactor renaming some of these values that are here in IMGUI build. How did I do all at once? All I did was right click. Again, I'm using, what I'm doing is I'm using refactor, right? So if I want to refactor target position, I want to right click and go refactor rename. And once I refactor rename, it launches this so I can change it all at once, right? It's part of ReSharper C++. Okay, so that's kind of why I use it. So everything changes at once, less typing, finger typing errors, which I don't want to make errors happen, right? Okay, so this is going to change the ship speed. Let's see if that works at all. So we're going to run it, and let's turn the ship speed way down. So I'm going to run it first, and before I launch everything, here's my max speed. Let's turn this way down to like 1, something like 1, and press start. So it should be really, really slow. And the reason why I want it really, really slow is I want to be able to see what's happening here. Notice how there's less jitter because it's really slow. So it doesn't, kind of miss the target too often. I can also reset it and make it really, really fast, like 73. And then you can see that there's more jitter, right, as it goes back and forth. Okay, so that's what I wanted to do there. Make sense? So that's what I want to, that's the max speed that I wanted to put for the ship. Okay, start and reset, and we can reorganize this panel later on. Next, what I want to do is after I have my max speed running, in debug mode, I want to be able to see where the ship is pointing. So we have some utilities that I can use. So if I go to Solution Explorer, and if I look inside my util under core, let's take a look at that util.h again, guys. I've included some draw functions for you. Look at that. Draw line, draw rect, draw circle, draw capsule. All right. And these are debugging convenience functions. All right. Where I can turn them off and on. So what I want to do is I want to draw a line, and the line is going to be drawn from start to end with a particular color. The default color is green. Okay, that's all I need to do. So just call draw line and it'll draw it. Okay, this is cool. Let's turn on that draw line for now all the time, and then maybe we can control it later. So going back to our code then, under spaceship.cpp, right? We already used the util function already, so we don't have to include it another time. We already included it. In the draw function, don't just draw the ship, but draw a line is what I want. So I want to draw the line, util, draw line from the source, which is the ship's starting position, get transform position to some destination in front of the ship. Now this is the challenge. Do I draw it up right now because my ship is actually angled up? So remember how up works. Up is wherever my ship is minus some value on the y-axis. That's what it is, right? Okay, I want you to consider this now. That means, is it always going to draw in that direction? Okay, hear me out for a second, how we're going to do this, because the draw line has to rotate, right? My draw line will rotate because the destination will rotate. Wherever I'm looking, wherever my direction is right now, is what I'm looking at. So for now, I'm just going to draw it straight up. Let's see if I can draw the line. So again, it's going to be a GLM vec2, and the vec2 is going to be starting at the same x coordinate, if you will. So the starting place is the start location, and I want to kind of put it up from where the x coordinate is up towards some value. So the x coordinate is going to remain the same. So get transformed position.x, right? And then on the y-axis, let's go a negative 20 pixels. Okay, hear me out. See what happens when I do this. So I'm just drawing a line for now. It's not going to change. It's going to just draw a line straight up. Okay, and let's see how this works. So run. And let's change the speed right down to 0 this time. So no speed. All right, and start. And there's my line. I don't know if you guys can see that, but it looks like there's a line that goes up. See that? If I change my speed, I can, by the way, I can change my speed faster and slower. All right, let's reset that. And let's start again. And let's reset my speed so that it is slow. Notice what it's doing. It's just drawing a line kind of up. Okay. And I made it minus, so it's off screen. Okay. But what I wanted to do was some value, right, offset from where my actual ship position is. Some value offset from my position. Okay. The place where it's looking. Where am I looking? Okay. So think about it as a direction that I'm looking in, or an orientation, if you will, which is what we talked about earlier. So we have a destination, we have a target direction, and now we're going to have an orientation. Okay. The orientation by default right now is 0, 1.
That's Control FW. Control
That,
delete.
that by the way,
you the one that tried
that you came on the line, buddy. I'm going to mute you. I'm going to mute you. Don't worry. All right. So the way it works is I'm going to make a new GLM vector 2. It's okay. New GLM vector 2. It's going to be M underscore orientation, right? And this orientation value by default is going to be 0, 1. Up for now. Okay. I want to set the orientation with a setter. Let's do that. Void set orientation. And we're going to set the orientation with a GLM vec2, and we'll say orientation. Okay. And what I want to do is define this setter. So I'm going to say the same thing as before. M underscore orientation is equal to orientation. Again, similar ways we've done all the setters so far. And inside of my constructor function, I'm going to set the orientation by default to a new GLM vec2, which is 0.0 and 1.0. Okay, so up. Now, is this up or is it down? It's actually down. Let's put up would be -1. -1 is up. No, no one said anything. It was just that he came online and by accident. It's okay. Okay, so 0 and -1. Does this make sense? So I've set up my orientation. If I set my orientation to 0, -1, that's my orientation. That's where I'm looking. And I want to multiply my orientation. That's the direction I'm looking at. Whatever my orientation is, right? Take a look. I want to replace my where I'm looking to. I'm going to take my orientation, which is M underscore orientation, multiplied by some amount. Let's say 10.0, 10 pixels, or 20 pixels. We can see it. And when we run it again, let's see what this looks like. And why am I drawing this line? So then when we rotate, we see how it's rotating, and we know how it's functioning. So again, if I bring this on board, I'm going to draw the speed to 0, and then I'm going to run it, and you're going to see that the orientation is 0, -1. So it's way over here. Is that correct? Why is it looking over here, and how come? Well, this is okay, but I need to offset my orientation because this is the position, the destination where it's looking, right? And that's not what I want, okay? Because it's got to be my orientation. It's got to be a direction that's wherever I am, my physical position, right? And I'm also going to be offset from where I'm currently at. So my orientation is not enough, right? When I set my orientation to 0, -1, I've got to also take into account my position. My current position has got to be taken into account. So wherever my current position is, I'm going to offset by -1. Okay. So I'm going to say that my current position, and now you can do everything. You can subtract it or minus it or whatever. So you can say something like m underscore get transform position minus. Let's see if how that looks. Okay, and what we want to do is we want to create that's the orientation. It looks like this for a second. Times 20. Let's see what that looks like. Okay, look at that. Is that right? No. So what is it we want? How do I redo this thing? So again, think about the original position when I draw my line is in the middle of my ship. That's my anchor. And then what I want to do here is I want to take my position, right? And I want to subtract 1 from it, right? And I'm saying minus times 20, but I don't want to times 20 here. That's wrong. I want to multiply my orientation by 20. So I can some kind of leader line. So it's like -1 times 20. Let's see how that looks. Let's go back, reset. So where is the line? And it's there. It's just you can't see it because it's not long enough. Let's try it again. So let's make it something like 60, not 600, 60. And let's see if it's going in the right direction. Nope. So we'll say plus for now because it's in front. And then we'll get a value that looks like this. So there is. So there's a little line that goes here. And then when I run this, when I press start, and if I increase the speed, it'll run this way. Okay. So again, start. You can see that the little line that draws this way. Why did I draw the line? What did I bother? Well, there's a couple of things we want to draw the line for. One, to visualize what it looks like. So where is it facing? What I want to do is I want to rotate the face by 90 degrees. I want to rotate the orientation by 90 degrees. Okay, guys, how do I rotate the orientation? I'm not just rotating I'm not just rotating the texture. I'm rotating the game object. The whole game object is rotating. Okay. I want to change the orientation. Okay. The setter for orientation is literally like this. That's all it does. And I'm just setting the orientation to 0, -1. By default, it's kind of looking straight up. Okay, what I wanted to do, right, is I want to rotate it to the left or to the right. That's what I want to do. I want to rotate to the left or to the right. Let's see if we can set rotation to something, or rotate left, rotate, whatever it's going to be, by some kind of degrees. Okay. How do I rotate is my question. How do I rotate across, the thing, the z-axis, if you will, because there is no z-axis, right? How do I do it? Well, we do have an angle, right? And the angle, right, is right here. Whenever we draw our object, which is right here, this is the orientation angle. Right now, it's at 0. So my assumption right now is 0 is straight up. Again, we can set up whatever we want. But right now, 0 means it's straight up. We need an orientation angle, right? And right now, our orientation angle is 0. and it's got to be in degrees. Let me show you what I mean. If I change this orientation angle to 90, right? If I change this orientation angle to 90, let's see what happens to the actual image. Which way does it rotate? So again, change to 0 and start. It's this way. So 90 actually rotates it to the right or clockwise 90 degrees. Okay. When we rotate clockwise 90 degrees, I want to rotate this 90 degrees. Rotate my direction, right? How do I rotate my direction? Well, think about it for a second, right? Math. We're talking about math again. So 90 is what I want to do. Let's try 180. See if that works exactly like we think it does. 180 should be basically pointing down again, right? So again, start. You can see now the ship is pointing down. Okay, so that's 180. It doesn't just rotate the texture, it rotates everything. So this is the way we're going to do it. We're going to do it through this rotation right here. I want to keep track of the rotation angle, if you will, whatever that rotation angle is going to be. What about if I go higher than 180? If I go something like 720, will it accept that? So if I right click or if I make it work and I bring it into play and I click start, yes, 720 would work, right? Because it's 360 and then 360, two 360s. It didn't error out is what I'm saying. All right. So this totally works. This is in degrees, right? And what we want to do is we want to put, instead of hard coding a value in here, we want to set the value, set the angle to whatever we want. The question is, do we have a setter that we can use right through our texture manager? We can do it here every time we draw, or we can use the texture manager function. We have set alpha and set color, but we don't have set angle. If I want to, I could make one, but again, we have this right here. We can just modify that value. How do I modify the value? Well, depending on where we're rotating, I want that value to be in there, whatever that is. Okay, and we're going to make a function that does it again through IMGUI, where I rotate what I'm looking at. And again, you can see how slow this is, guys. I'm testing, right? So let's, again, we're just throwing a bunch of properties right now at our spaceship, and we may eventually eliminate some of these, but right now we're not going to do that. So target direction, our destination, our orientation, and the orientation is a vector, whatever that is, and we also want a rotation angle. So it's going to be a float. And we want to set the rotation angle. Wait, rotation? Wait a minute. Don't we have all this kind of stuff? Well, we do. For now, I'm going to leave this as rotation angle, but I just want to point out that there's a couple things we have here in components. One, in the transform.h, we have a rotation vector, which we can use as orientation. Putting that, we're going to probably do that later on. Transform.rotation is going to be the orientation. That's what we're going to use, okay? 0 to 1 and all that kind of stuff. But for now, let's use a rotation angle as something that makes sense to us, which is something that we're going to use in our file. So m_rotation angle. I'm going to make a setter for this to a GLM vec2, a float angle, just like before. And we're going to go into generate implementation, where I basically say that, inline. No. I'm going to set the orientation. I don't want it inline. Why did it give me inline again? That is really weird. Sorry. Let's try that again. Don't want inline implementation. I want implementation. All right. And where I'm going to say that M underscore rotation angle is equal to angle, whatever that's going to be. And by default, what I want is for the rotation angle to be here, right? And I want to set the rotation angle by default to 0. Right? Hear me out for a second. We're going to reduce. First, we make it big, and then we come back and reduce. Okay? So the reason why I did this is so I have control over the rotation angle of the object. When I rotate, then what I want to do is when I set rotation, I'm also going to set the orientation. They're related, right? And for now, they're separate, but eventually they're going to be tied together. All right, so 0 minus 1 is straight up, and so is the rotation angle of 0. Okay? What I want is inside of my game object, inside my placing.cpp, just like I have max speed, right? I also want to set the rotation with a slider angle or slider float. It doesn't really matter how you do it. If you look at IMGUI slider angle, right? What does it need? It needs a label, something in radians, something in degrees. Look at it. Look what it looks like. A radians, a degrees. That's minimum of negative 360 and a maximum of positive 360, right? And some kind of format. So again, this is the thing that's weird. Radians and degrees min and degrees max. Okay, which are default values. So I need to change it from radians, you know, and I don't have also one thing that I can set the slider angle as an example, whatever that's going to be, and we need some kind of object that's in radians. So static float that's angle in radians that we're going to set up by default to be 0.0f. And we're going to pass in the name, which is orientation angle, right? And we're going to say that we're going to pass in a reference to the angle in radians. And we're not going to pass in degrees or anything like that, where we have a float and minimum degrees and maximum degrees. We're going to say that if my slider angle changes, then what I want to do is I want to use this angle in radians and convert it to degrees, whatever it ends up being. So the way that works is I'm going to use a utility function to do that, right? Util has a rad to deg function, rad to deg. So I can do something like, and then we're going to finish after this, guys, because I know I'm tired. You must be tired. I'm going to say that m underscore p spaceship, right? I want to set rotation again to the angle in degrees, but I get an angle in radians. So angle in radians multiplied times util, and then there is, I'm going to include the dot h. Oops. There's something called rad to deg, which converts it to degrees. I know, it's crazy. Let's see if this even works. It's going to be on top of each other, underneath the speed, but in angle and radians. Let's see if that works at all, or if I just totally messed up. Again, one thing you're going to notice is that the line isn't going to change because we haven't changed that. So we'll make the speed 0, and our orientation angle is 0 degrees, right? If I was to start it. And if I change this thing, you can see that I can change the orientation angle as I want. This is great because it shows us what the orientation angle is every frame. Okay, actually, this is not going to update. This is setting. It's not getting, right? I'm just putting it up there to you. In order for us to have this change as an example, then we need to use a getter for this, not a setter. Okay, right now it's rotating. So what I want is when this rotates, I want this line to rotate too. How do I do that? And how do you recommend we do that, my friends? Here's the line. The line is I have an angle, whatever that angle is. The angle is in degrees, an angle in degrees, right? Remember what an angle in degrees. Can I get, if I have an angle in degrees and I want to convert to X and Y coordinates, normalized coordinates, right? Can I go back and forth, right? Well, we know that if I have the components, the X and Y components in a triangle, going back to this, right? If I have a triangle, let's draw some triangles. Again, everything is triangles in our world, right? So let's suppose I have a triangle for this, right? If I have let's suppose there's a destination from here to there. Let's suppose that's the destination. I know I have an X value and a Y value. I know that this X value and Y value is also has a right angle. It looks like this. Oops. Right, there's the right angle, right? Approximately. So we know this is right angle. We know what this is, and we know what this is. If I know two sides and an angle, can I figure out the third side? Right? I know. Triangles and boxes and angles and all that stuff. We know this, right? We know this one. If I know this angle and I want to solve the triangle, I know that the internal angles add up to 180 degrees, right? I know that. I've got 90 here. And if I have, if I use SOHCAHTOA, right? Okay, if I use SOHCAHTOA, SOHCAHTOA stands for so again, hypotenuse is the H, sine is this one, opposite. So sine is equal to opposite over hypotenuse, right? So this is hypotenuse, this is adjacent, right? And this is opposite. Cosine is equal to adjacent over hypotenuse. That's what this is. Okay, adjacent over hypotenuse. Okay, that's how these angles work. Okay, so if I'm rotating, whatever the destination is, as an example, it's going to be, the angle is going to be a cosine of, and because I'm always going to get this near angle, this adjacent object, whether I'm up or this way or wherever I'm going. So it's going to be ka, right? Cosine of the adjacent over hypotenuse. Adjacent over hypotenuse. All right. If I know that, if I know what the components are, right? Because I'm going to get my orientation, I'm going to get the components of these things, then I can find the angle. But that, we're timing out, guys. It's 5:53, and I'm not going to do it this way right now. I'm going to show you this another day. But that's how you would do it. You get the angle, and once you get the angle, you start rotating the line. As this line rotates to the right, you rotate the line, the destination, whatever this orientation is going to also change. Orientation is super important because that's the way we're looking, right? Once we know what the way we're looking is, then we can take that. We have the angle already, right? I've already got the angle, right? So the angle is 30 degrees. Once I have the angle, I can get the other pieces as well. Can you show the body of this? Sure, I can. So, sorry, that would be in playscene.cpp. So slider angle is really cool because it gives us degrees. It says, hey, here's the number of degrees. You know, I want to rotate 90 degrees, and it's going to give us an angle kick us back an angle in radians. and I can take that angle in radians and do something with it, or I can just convert it back to degrees. It's up to you. So learnings as we depart for the day, right? Let's make the getter. Yeah. If you make the getter, yeah, let's not do that right now. So this is the set rotation. The getter would be here. So I get rotation every frame, right? Be careful, because if I go to my ship, go to definition for the ship, then right now what we're going to have is my spaceship.cpp. Here it is. I would need a getter for the angle. So let's say void get rotation. And again, we're going to store this differently later on. And what it's going to be is I'm going to return a floating point value for the rotation, right? So then what I can do is I can go here and generate implementation. There it is, get rotation. I'm going to return the m_rotation angle. That's all the getter looks like. And because I'm returning something that's constant, it's going to say make the function constant. I agree. So it's going to return a constant value, which is the rotation angle. Now that I have a getter, since you've asked for it, I can go back to the placing.cpp, and instead of me setting up my angle in radians here, I can set this to whatever the angle in radians is. Be careful when you do this though, m_p spaceship, and then if I say get rotation, now I'm getting rotation and I'm setting rotation. Be careful about this, what it's doing, right? So if I run it, one thing influences the other thing. So my rotation is 0, and if I modify it, right, and if I start, you're going to see it starts right away with an angle of 89, right? Right, so if I start it, you can see that the angle starts this way. I can change the angle to whatever I want, and if this changes the angles, if this changes the angle by itself, as an example, then what ends up happening is, so too will this show what the angle is, the actual angle. Also, we can modify some stuff, and if I start with some kind of value, you can see that it goes this way. It doesn't change the direction. Another day, can you do a short video about setting up ReSharper? Yes, we can. All right. Again, starting off, we're getting there. There's still more work to be done here because we're not moving in the direction. But first of all, we have to know what the direction is. Right now, our direction is whatever angle we set. And what we want to do is every frame or every other frame, I want to have some kind of turn rate, which I don't have. And the turn rate, what's going to happen is it's going to continue to turn. Let's put this back to 0. Every frame, let's say, for example, it might turn the ship slowly, slowly, slowly. And wherever the ship is looking is the way that I want it to go. Okay. And the way to do that is, just to really quickly, v cos theta, v sine theta. So the next y position, instead of me going here, that's the destination. But what it's going to do is going to change the position of the object according to the velocity. So the velocity, instead of it being just the destination, is there's going to be, I want a destination, I want to get to a destination, I'm going to turn towards that destination, but I'm going to actually have a velocity that's going to move my object in any way I'm looking. Okay? So again, if you think about it, my velocity times cos theta, cos of the angle, is going to be my x, my next x, right? And my velocity times the sine of the angle is going to be my next y. And if I take those two things, that's the next position that I'm going to move every frame, right? Based on my, multiplied by my max speed. Oh, thank you, Ethan. I appreciate that. Okay, I know you have questions, but this is a good start for you guys to get going. Again, we're building here. We have a lot more work to do, but it's a good start for us to get going. Any questions before we go that I can handle in a few minutes? I'm going to stop recording, by the way, and this way we'll have a chance to talk offline. For the people who are watching on YouTube, I'll see you next week. Good luck with your assignment number 1. For the people that are here, I've stopped